We're diving deep today into what I think is a really compelling paradox in human evolution. Why do genetic variations for conditions like, say, OCD or bipolar disorder, why do they stick around?
Right. If they cause so much difficulty, you'd think natural selection would have just gotten rid of them.
Exactly. So our mission for you today is to kind of shift the frame on this, to see neurodivergence less as a pathology.
And more as a distribution of these incredibly powerful cognitive strategies. Strategies that gave our ancestors a real edge.
Okay, so let's start there. What's the mechanism? How does that work?
Well, it really comes down to what we call the threshold model. You have to understand, these are highly polygenic traits.
Meaning lots and lots of genes involved.
Thousands, yeah. So it's not like an on-off switch. It's more of a dimmer. Think of a trait like attention or energy. It follows a bell curve.
A normal distribution.
Exactly.
Yeah.
And if you're way out on the extreme end, you hit the clinical threshold and face impairment. But this is the key. If you're just below that threshold,
You get the benefit.
you get the dilute version. All the superpowers without the full debilitating cost.
Okay, so let's unpack those superpowers. Let's start with OCD, which you've framed as the sentinel phenotype.
Yes, the sentinel. It's essentially an exaggeration of our evolved harm avoidance system.
So what was the function? What made that level of vigilance so valuable?
It's about foresight.
Yeah.
We have this system called the Involuntary Risk Scenario Generating System, or IRSGS.
Bit of a mouthful.
It is, yeah. But think of it as your brain's built-in simulation software. It lets you run endless offline scenarios of future threats.
Like contamination or a predator or a fire.
All of it. And you can do that without ever having to actually face the danger, having someone in the group who did that constantly. The Sentinel, that was a massive advantage.
And I was fascinated by the cognitive trade-off that comes with that. The sources mentioned this spiky profile. People with OCD might take way longer on certain cognitive tests, but they make far, far fewer errors.
That's it. They are prioritizing accuracy over speed, absolute precision. And you can see how valuable that is. It connects directly to the contamination fears.
The behavioral immune system.
Exactly. An ancient psychological program for avoiding pathogens.
Yeah.
The person who was hyper-vigilant about hygiene, they didn't just protect themselves, they protected the whole group.
So the Sentinel is all about safety, precision, conservation. Let's pivot to the other end of the spectrum. Bipolar disorder, the resource mobilizer.
Right. The EOBDR hypothesis links this to climatic adaptation. Back in the Pleistocene, the environment was, well, it was harsh and unpredictable.
So mood became a survival strategy.
It became a metabolic strategy. In this model, depression isn't just sadness. It was a conservation state, like a form of hibernation during the long, dark, resource-poor winters.
And mania.
Mania was the opposite. It was the hypermobilization strategy for the brief but intense summers, a huge burst of energy for gathering, for productivity, for reproduction.
Which makes the connection to creativity so clear, the inverted U model.
Yes. Creative potential seems to increase with genetic loading for bipolar risk alleles, but only up to a point.
So first-degree relatives often get the good stuff, the divergent thinking, the high verbal IQ without the full impairment.
That's the idea. You get that intense ambition, that openness to experience. It's why you see so many leaders and artists on that spectrum.
So how does this all translate to today, to the modern economy?
Well, we've kind of built perfect economic niches for these spiky profiles.
How so?
In cybersecurity, for example. That sentinel-like precision and pattern recognition. It's a superpower for things like reverse malware engineering. And then you look at creative industries.
I saw one study that said nearly 50% of people in that field identify as neurodivergent.
It's a natural fit.
Like it.
But, and this is the big caveat, there's the evolutionary mismatch.
Right. If these were such great adaptations, why are the clinical symptoms so agonizing for people today?
And that's the crucial point. The adaptation isn't the suffering. The suffering comes from that ancient software being triggered constantly and maladaptively by modern stressors.
Chronic stress, light pollution, urban density.
It's a toxic environment for our ancestral brains. The modern world turns these advantages against us.
So the big synthesis for you then is that this isn't a biological error. It's this complex, essential tapestry of strategies.
Absolutely. The sentinel who watches the perimeter and the mobilizer who envisions a whole new world. You need both for a species to innovate and succeed.
They're both crucial.
So I think the final thought to leave you with is, what if we focused on that? On minimizing the triggers, What kind of accommodations, sensory-friendly workspaces, flexible hours would allow these specialized minds to contribute their skills without pushing them into the pathological extreme?
Allowing the Sentinel and the Mobilizer to thrive.
Exactly. That's where the real societal innovation is waiting for us.